I'm Mike Blundell. I'm an Associate Dean in the Faculty of Engineering and Computing at Coventry University. I'm also a professor. I'm Professor of Vehicle Dynamics and Impact, and I head the Vehicle Dynamics and Safety Research Group at the university. The helisafe project was a European project funded under Framework 6. It was aimed at improving the opportunity and the chance for survival in the event of a crash of a civil helicopter. Rather uniquely, we looked at putting an airbag in a helicopter as part of the project, something that had never been done before. So you would guess that there was a lot of transferability from other disciplines like the automotive industry, which has an established record of developing occupant protection systems in vehicles, and where airbags have been established for more than 30 years. There were 12 partners in the project, a range of activities across the consortium, developing new harnesses, developing an airbag specifically for a helicopter. But at Coventry, we were extensively involved in carrying out the computer modelling and simulation to test the concepts before you implemented them in a physical helicopter crash structure and did full-scale testing, which is very, very expensive. So there were some rather unique aspects to the work we did at Coventry. Nobody had actually modelled occupants on a computer in a helicopter crashing in these scenarios with airbags deploying and automotive-type restraint systems with pre-tensioners and the sequence of activating those occupant protection systems was extremely important to ensure that they were effective. So, for example, there was a lot more attention to the injuries in the spine because of the vertical nature of an air crash compared with an automotive crash, which tends to be predominantly in a forward direction. The things we developed, we were the people who, for the first time, used this software dummy, demonstrated it, applied it and proved it. And in fact, our results were validated by the full-scale crash tests performed by the partners on the project. As I said, there were 12 partners in the project, and they were a mix of universities and private companies and large-scale test institutions. The main partnership, I would say, that we developed was with T&O, a very well-known Dutch company, particularly the automotive safety division there, TAS, T&O Automotive Safety Systems. They developed the software that we used on the helisafe project. It's well known in automotive and aerospace circles. It's called Madimo, and we've had a stream of projects running with them. So apart from helisafe, we've also run PhD projects with them here at the university, quite diverse areas of application, automotive pedestrian impact protection, so modelling cars hitting pedestrians to design cars to be more pedestrian friendly, looking at modelling cars when they roll over, quite a challenging thing to do in a computer simulation environment, and more work on airbags. Airbags are hugely complex engineering systems to model. You need to model the fabric, you need to model the gas flow into the airbag, you need to model the way it deploys, it vents the gases, and then you need to model the way that it interacts and protects the occupant of the car, or in the case of helisafe, the pilot of the helicopter. And that's actually very complex, and we're moving on now to further challenges in that field, where we'd actually like, rather than modelling crash test dummies, we'd actually like to start modelling human beings in cars, so trying to actually build physical models of flesh, bone and tissue to design and optimise these protection systems.